Sure, sure. Okay. So an example of a sine wave that we've talked about here would be something like sine 1/2 x to -4 plus 2. And the first thing you always do is figure out the period. Could you calculate the period for this one?
The period would be the
2 pi over b. B is the number in front of x.
4 pi.
4 pi. The reason that's so important is it tells you how to scale your graph. You know that sine looks like this, and it tells us where to kind of put these markings. Okay, that's 4 pi. And then you need half, and then half, and then half, like that. And then I do like to draw that parent function thing right there. All right. The next thing to deal with is the amplitude / the reflection. You can maybe do those together if you're comfortable. But what it does is it pulls up or down all the points. And you have to do this before the vertical shift is last. You deal with that completely last. So it's easy for me to go to another color here, but the 4, 1, 2, 3, 4. 1, 2, 3, 4, and there. So the 4 does this. It just pulls it up and down like that. That's the 4. The negative flips it completely. So if it's up at the top, it goes to the bottom. If it's at the bottom, it goes to the top. So basically switches directions like that.
Okay.
All right. So that takes care of that. Then the third thing you deal with is the vertical stretch. I'm going to change this to -2 because I'm running out of room. So I'll do that in green here. This is the vertical shift, up or down. In your case, it's down 2. So everything goes down 2. So from the blue, basically the blue, all the points in blue go down 2. So down 2, down 2, down 2, down 2, down 2. And then you graph, you kind of connect those as well. Sometimes they want you to graph more than one period. Did your instructor mention anything like that?
Yeah, there's some, if you look at the images I sent you, some of them are 2 period intervals
Right,
as well.
but your instructor might specify more, like it's really specific to the instructor. Like the textbooks are the textbooks. Like what some instructors do is they say 2 periods. And like once you get your final graph, it's not that bad because you're just replicating it. So you're just carrying it on to
She
another.
asked for she asked for 2 periods for tan, but I don't think she wants. Oh wait, no, she does want us to know how to do 2 periods for sine.
So the other thing that could happen is they might tell you they want both a left period and a right period. And I always go out to the right if there's an option. Like it's way easier just to keep going than to try to go left. Left creates all kinds of issues. Um, you want to make sure you label these appropriately, things like that.
Could we do 33 on the first image I sent you?
Sure. So this has a phase shift. This is a very challenging problem for new graphing.
Oh wait, no, the one that says for each. Yeah, that one. Sorry.
This one here or not?
Yeah.
Okay. So this one, You don't have to graph, but we should graph, but it is pretty hard to graph for most students. This is really a challenging problem. To figure out all of this stuff, though, you start by factoring out this thing, whatever's in front there from both of the terms inside parentheses. It's always a little awkward when it's a fraction. So sometimes you have to like almost like guess what goes here and then multiply in and see if it actually worked, which it does in this case. Um, it can be a little awkward. Like when it's a whole number, you divide it, but when it's a fraction, you end up multiplying it just to figure, going backwards and forwards. But that's the first part because that's actually the b value. The b value here is 1/2. And the period, you always start with the period. It's 2 pi over b. So this one ends up being 2 pi over 1/2, which is 4 pi.
And if we can't pull out a common factor, then
You always
which
can. You
number
always
would be the b value?
you always pull out what's in front of 1/2. It's not a DCF. It's just whatever's in front of the variable you pull out.
And that's always the b value?
Yes,
Okay.
always. But the C, which is the phase shift, is not the pi over 2. The phase shift, and sometimes books like show you it's like C over B. That's not the right way to do it. It's better to factor it out. And then this thing on the right here is the phase shift. So the phase shift, which is the horizontal shift, is pi, and then you have to specify whether it's right or left. In this case, it's pi left.
Okay. And then the
Is
vertical
that okay?
translation?
We're gonna
Yeah.
get to that. There's an order. There's always an order here. This is the correct order. This leads to how to graph it. Next thing is amplitude. Amplitude is the absolute value of the leading coefficient, which is 1/4. And then the vertical shift, there's nothing on the outside, so it is none. Any questions on this?
Uh, no, I think that makes sense.
Okay, we should talk about how to graph this because this is
So
kind
would
of
there not
brutal.
be a vertical shift on any of those questions in that section?
That's right. So they tend to not
Okay.
include all of the possibilities, like when they're in the textbook, but your teacher could. I mean, your teacher, as you've seen, is giving you pretty challenging problems. Okay, normally cosine starts at at 0 and you go down, up, down like that. But the phase shift throws everything off. It's pi left. So the way that you could do this, which I don't like, the way that you could do this is you could go left pi. You could say, all right, that's minus pi. I don't really like crossing the y-axis with these graphs, especially when you're doing by hand. It's really what I would tell you to do, which is not taught typically, is I say to if it's left, you take the phase shift, and then you add the period. And that's where you actually start. You start at 3 pi. I would tell you to start your graph at 3 pi, not minus pi.
For it to line up?
Just to make it so that you're not crossing the y-axis, which can get dicey if you don't really understand what you're doing.
Okay.
That's me. I mean, you can start pi left. So if you start at 3 pi, you still have to go at one period, which is 7 pi. And then now you can draw your parent function. Go down, come back up like that. So always start with the parent graph. Like I don't worry about the amplitude, reflection. I just get, you kind of have to deal with like everything. So you deal with the phase shift and the period together. Now, in all the problems we did last time we did a lesson, we just had period changes. phase shift and period work together. Let me know if this is
That
clear or
makes
not.
sense.
Okay. Then we deal with this right here. So the 1/4, and this is where I don't really like these problems because they're so squeezed in. But 1/4 means you're everything is getting really really shallow. There's 1/4 and minus 1/4, and then the negative flips it. So the negative flips it to the other side. I think I even mentioned maybe taking colored pencils or pens in.
Okay.
I really like it. Okay. So if you need two periods, I would just go out another. I would always go to the right with the periods. Would never, never, never try to go left unless I was forced to. And sometimes what they do is they um, make you like they pre-print the axis and then you have to like go left.
Okay.
Any questions or thoughts on that?
That makes sense.
Right. Why don't you pick out another problem or two because it seems like you've maybe got your eyes on some that would be more useful than me just sort of lecturing because I don't teach your class, even though it would be good if I did, but that's not what you guys are. You have specific problems I'm sure that you want. Um,
Um, could we do 38 or 37?
sure. So 38, it's fine. I might make a small adjustment just because they get such a pain when they're fractions to deal with the amplitude. If
Mm-hmm.
you're okay, I'd like to change this to a 2 or something. Is that okay? Does
Uh,
that matter? Does that, or do you have to have it? I mean, is this a homework is problem?
yeah.
Okay. I'll do that. All right. First thing is to factor out the 2 inside the cosine. Typically, you alternate brackets and parentheses, and then I kind of prefer to have the vertical shift over here, although most textbooks do it as b plus a cosine b x minus c. But I don't think I just think it's weird when it's right there because you're so used to it being over here in all the other courses you've been. So the period is 2 pi over b, which is pi.
Okay.
All right. So that's thing one. The phase shift is 3 pi over 2, but the direction matters. It's right. It's right because of this minus sign here.
Okay.
Okay. Next thing is the amplitude. The amplitude is the absolute value of 1/2, which is 1/2. And then the vertical translation, it's that number on the right now. It's down 1. Any questions, thoughts on that?
Um, no, that makes sense. Could you graph it though?
Sure. And that will that will demand that we change that one half to something else when we graph it. Really, it just gets really awkward. If you do, is that okay?
Okay.
I'm gonna take that as you really you're supposed to graph these as is. The
I
the, the
mean, we
one
don't have
half's
to
just
graph this problem, but like just in case, I was.
I see. The issue is that it's just hard to graph one halves by hand without, and I don't want to change, like what I actually prefer is to just change the scale of the graphs, but you should probably won't appreciate that. So normally cosine starts at 0, but this time you're going to go 3 pi over 2 to the right. And the question is like, well, where is 3 pi over 2? Now, you could literally put it anywhere. It does not have to be like to scale, but that's where you run into issues. Like, let's say you're graphing this on your exam and it's pre-marked, you got to put it in the right spot. So I'm basically saying each of these is a pi over 2. So one period is pi. So this is again where I don't really like this, but like because one period is now 5 pi over 2. So our entire cosine graph has to fit in this little window. I don't know why teachers do this because they're hard to grade. I mean, so the cosine graph has to hit all, let me do it correctly, 5 points there, there, and there. So here's your cosine graph in that little window, 3 pi over 2 to 5 pi over 2. Because the period is way too wide. Period is pi.
Wait, if the isn't the period 2 pi over 2, so the period would be pi, which means it'd be 4 pi over 2?
At 3 pi over 2 plus pi over 1 ends up being, when you make the common denominator, 2 pi over 2. That's
Oh,
where,
oh, okay.
okay. All right. So good question. You got to get that right. But now we got to do all the other stuff. So um, if this is 1, this is a problem I have with these. Is like because of the 1/2, it's like now I mean, I don't know how you even do this with a pencil. Just got to write really small. You're shrinking it by a half. So it looks like this. That's dealing with the 1/2. And then the down 1, you're moving every point down 1. So instead of it being at a half, it's going to be down here at -1/2. That moves down to -1, -3/2. And it's like you're trying to cram all this stuff into this little tiny space, but you can do it. If you needed a second period, you'd go out 1 more pi, so you get to 7 pi over 2. And then you just got to replicate what you have there.
And then can we do 37?
Sure. Okay, so for this one, what I would like you to do is tell me what goes in parentheses after you factor out the 3. Do the, give them the best you can.
pi over 15.
X minus pi over 15. All right,
Yeah.
so could you give me the period for this one?
2 pi over 3.
2 pi over 3. Good. And then the phase shift is the number inside parentheses. It's pi over 15, but is it right or is it left?
Right.
It is right. And I like seeing that word. Sometimes you don't have to put that, but I think most instructors know that that's the right thing to put down. All right, amplitude now. What is the number in front that is not written in this case? What are you taking the opposite value of in front here of sine?
1.
-1. It includes the sign. You're taking the absolute value, so it ends up being 1. And then vertical translation is up 2. Now, if you look at what I wrote and what the original is it clear why it's +2?
Yeah.
Okay. All right. So there you have it. There's everything for this. Now, graphing this one, your teacher, you always sort of commented a couple, a while back, and the teacher gives you really tough problems. This is a really tough one to graph by hand. So we should do it because that's what your teacher probably will give you. Okay. So you start at pi over 15. Well, where is pi over 15? Well, I guess I'm going to call this pi over 15. But like I said, sometimes you get like pre-marked ones and you got to kind of like figure that out. But you're going out one period. So you're going to go out pi over 15 plus 2 pi over 3. Could you add these together? You have to make a common denominator for that.
Add what to make the common denominator?
Add these two
Oh,
together. And that, like the analogous problem is what is 1 over 15 plus 2 over
11
3?
pi over 15.
Yeah. So this is where it's like your index, your increment here matters. So if this is 1 pi over 15, I got to go out to 11 pi over 15. So you start counting 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's 11 pi over 15. You do need to get the midpoint of them, which is 6 pi over 15. Your teacher is potentially grading you on that. Okay. So now we can graph sine. So sine starts here. It comes back down. So you got to also find the midpoint here, which is 7 pi over 15, which is kind of right in the middle here. And then this is going the other direction, 8.5 pi over 15, kind of right in here. So this is your parent function for sine. Dealing with the phase shift and the period.
Mhm. Would we not move it up 2?
We will. That's the last thing you do. Next, we're going to reflect it. I do not recommend you try to do this all in one step. It just can get really bad. So there's the reflection. And then now you can go up 2. You can take every single point and go up 2. So there's up 2. There's up 2. There's up 2. There's up 2. And then there's up 2.
Okay.
And that's it. And if you had to go out one more period, you'd have to add 2 pi over 3 to 11 pi over 15 and draw the same thing. Um, what I'm trying to let me see if I can pull up an image. So like what some instructors do, which would be brutal, would be to they actually will put something pre-printed on your paper like this, and then you got to figure out where like pi over 15 goes and 11 pi over 15 goes. And so like in this problem, you'd be trying to do everything kind of like in this little region right here. Like this whole graph would fit in this part because of the way this is scaled. Is that okay? All
Yeah.
right. What would you like us to look at next?
Could we do one of the 2 period interval questions?
Sure. Yeah, why don't you pick one? I mean, they're maybe, something that stands out to you.
Um, we could do 43 and 44.
Okay. Okay. Um, so what is the period and the phase shift? Have you start with that?
The period would 2 pi.
Goodbye. Yeah. About the phase shift.
Um, pi over 3 to the right.
Right. Yeah. Okay. So like this again, I'll make this one more of the emphasis. So like on a typical graph, like this might be pi over 2, and this would be pi, and this would be 3 pi over 2 and 2 pi. And it's like, where does pi over 3 go? And that's my question to you. Where do you think it goes?
The what?
Where does pi over 3 go?
In between, oh wait, in between 0 and pi over 2.
Okay, good. So somewhere in there, right? So that's where this gets a little bit, what are you doing? Okay, so that's pi over 3. How far out do we go? Well, we add the period 2 pi. What does that become?
7 pi.
7 pi over 3. So where is that? Well, it's right of 2 pi, so it's right about there. We'll say 7 pi over 3. And this is that whole point of like it's kind of awkward to graph something like this when you're given a pre-organized, because then it's like, well, where does the other stuff go? Well, we know that cosine goes down and comes back up like that, something like that. So then what do we do now? Well, we've got the amplitude to deal with. So let's change that. So instead of being at 1 and -1, everything's going to go up 1. I'm sorry, it's going to be scaled. So I went too far down on that red one. Let me redo that. You can see the problems when you get these ones that are pre-done for you. They're just not the best. Like that. All right. And then two periods, well, you're just going to go out and replicate. So it's like, okay, sorry, that's 3 pi and then 5 pi. So it's essentially going to be a repeat of the same graph. It's just going to finish somewhere kind of over here. So it's going to look something like that if you want to go out two periods. And again, this one's pre-scaled, so it's more difficult than doing it on your own.
But why would it, if it's two, why would it be one, like the middle?
What do you mean the middle? Which middle?
Like the y-axis reference.
Why is it two? A negative two?
Oh, so if it's two, that would just be like the bottom of it, not the.
Yeah, that's the top. That's the amplitude.
Okay.
If you have more questions, please ask. Sometimes it's hard because and maybe you're like trying to point at something and I don't know what you're pointing at or referring to. Just try
Could
to
you
give me a
just
little more
explain
words.
how you did that amplitude again?
You pull up anything that's at one. You're doubling all the values. So this one in black is one, that goes to two. Zero stays the same because when you multiply by
Where?
zero, nothing right here, where the y value is zero there,
I don't see your cursor.
right there
Oh,
where the
now I do.
black yeah, right there it's zero, so it stays zero. Here it's negative one, so it becomes negative two. You're multiplying by two. And then same thing here, that zero stays zero, one goes up to two.
Okay.
The other way to do this, which we've not done at all, is to use a table. And then you would see like the scaling, multiplying the y values by two, because the amplitude is a multiplication by two from the y values.
Okay.
All right. 44. Okay. Give me the period and the phase shift on this, please.
Period's 2 pi and the phase shift is right 3 pi over 2.
Good. All right. So this time when we graph it, we're going to choose our own scale. So 3 pi over 2 and 2 pi, you kind of like want to be like, well, how do I get to 3 pi over 2? Like what increments make sense so that I can still get like 2 pi out of it? And if they're each pi over 2, then 3 pi over 2 is there. And then when you add 2 pi to it, you get 7 pi over 2. So this is 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2. And so you always go out the phase shift and then increment the period. So then a sine wave starts there, goes up, comes down, comes up. That's the parent function. That's the 1 and the -1. So always start by doing the period and the phase shift. Then uh, you multiply by 3. So if I were to make a quick table here, that's what I was kind of alluding to, x and y. At 3 pi over 2, it's there. At 2 pi, it's 1. At 5 pi over 2, it's 0. At 3 pi, it's -1. And at 7 pi over 2, it's 0. So the 3 in front is multiplying each of these by 3. So that's why it's like pulling up, pulling down. So 0 stays the same, but 1 goes up to 3. -1 goes down to -3. So it's just pulling up the ones that are not on the x-axis.
Mhm.
And that would do it. Now to go out another period, right? You got to add another 2 pi to this, but it's just counting now. It's just okay. Well, 2 pi. So 1, 2, 3, 4. That's 11 pi over 2. That's 9 pi over 2. And then you just repeat the red part like that.
Okay.
It needs to look the same each time. Like if you could digitally, you would just copy the first one into the second. Hopefully I'm making a good case for the order to do these in.
Yeah, that makes a lot of sense.
I don't even know how they teach this, but a UHS student had a really crazy teacher with these problems, but this approach worked fine because you just manipulated them, weird fractions and stuff. You just had to manipulate the fractions, but they always look the same when you're done.
Mhm.
So, what else? We need something kind of short here. I do think you'll be asked to go backwards, but I don't know. Already did that one. I don't know. Yeah, I haven't really asked you to do one, so let me just give you one here. Let's talk about tangent and cotangent real quick. This is important.
Can we do the
And
2 period interval?
for we
Oh
did
wait,
two.
no,
Yeah,
yeah, never mind. Sorry.
so let me just make some quick comments on tangent, cotangent. This will lead us into tomorrow. Tangent and cotangent, um, they have a period of pi, very different than sine and cosine, secant and cosecant. So when I tell you like tangent 1/4 x, its period is pi over b. So pi over 1/4, 4 pi. That's the first thing. Did your teacher cover that with tangent and cotangent?
Yeah.
Okay. Any idea what a tangent graph looked like?
Mhm.
Just a straight tangent graph.
It's the like vertical squiggly line.
Now, why? It's because sine of x, tangent sine of x over cosine of x. Do you remember what happens when when the bottom is equal to 0? Well, that's called a vertical asymptote. So where's cosine x equal to 0? At pi over 2 and minus pi over 2. That's why it's there. So if you were to graph a cosine, you would see that. Let's see if I can, well, we'll do that tomorrow. But your graph looks like this for tangent. One of the things that would be good for me to know to be able to help you is how many points your teacher wants for the tangents. Usually it's 3, but If it's more than 3, it gets really, really complicated.
This
Uh,
one's 3.
oh, good. Not too nuts. What is it? Do you remember how a cotangent looks? It's kind of related.
The opposite direction.
It is, but it's got a 0 and pi because cotangent of x is really cosine of x over sine x, and sine x equals 0 at pi. So yeah, and it goes the other way like that. And you do got to know that. You got to just have those down to be able to do anything in them. All right. So let me go ahead and stop there. Any interest